Hello, what is up? Welcome back to the Squiddish podcast. This is episode 4, season 1, and my name is Mel. Today we're going to continue our deep dive into, of course, cephalopods, and we're going to be focusing on chromatophores and the way that certain cephalopods can change their appearance in order to blend into their surroundings. So, cephalopods aren't the only animals that are able to adjust their skin to their surroundings. There are also plenty of reptiles, fish, crustaceans that are able to do the same thing, and also their skin also contains chromatophores. So you can sort of think of chromatophores as sacs that are just below the skin, and if you imagine like a piece of bread molding, and you kind of imagine that mold kind of stretches out from a couple points and just continues to grow from there. That's sort of how they work, except they work obviously a lot quicker than mold on bread. So I was recently directed to a pretty incredible and very short TED Talk by David Gaio called Underwater Astonishment, and in the video he addresses how octopus change color and why it's so impressive. So not only do they change to the color of their surroundings to blend in, they match to the pattern, they match to the texture, and they completely match to the brightness. They get all the shadows correct. So there are two main elements to chromatophores, biochromes and schemachromes. Biochromes are visible light, the visible light spectrum. So they kind of help the cephalopod to achieve colors that we would know, like reds, orange, blues, greens, etc. And then there are schemachromes, which don't produce actual pigments themselves, but are actually colorless, and they produce iridescence, so silver and gold, and they do this by diffusion and scattering of light. So there are other chromatophores present beneath the skin of a camouflaging cephalopod. They contain other specific carotenoids and other pigments, but they all fall into these two distinct categories. Now, there are other chromatophores that exist that can contain specific pigments and carotenoids, but they all fall under those two distinct categories. Now, something really interesting about octopus, squid, and others is that they're actually completely colorblind. And the reason for this is that most cephalopods only have one photoreceptor, so they can only see black and white. They have huge pupils as well, and the larger the pupil, the greater the chromatic aberration. So chromatic aberration is also called like chromatic fringing or color fringing, and it basically means that the lens of the eye does not refract light correctly, so that colors get all mismatched and then there can't really be a focus on one specific color. They don't blend correctly in the eye. So as you can imagine, this is actually a very intensive way of seeing the earth and colors. The octopus, squid, and other cephalopods have to work extremely hard to be able to interpret their environment just through color refraction, and their eyes actually are very blurry. The sight that they see is very blurry. They're almost totally unable to focus, and when they can focus, that's how they finally know what color they should be changing to. So this is sort of one of the reasons why scientists believe cephalopods are the most intelligent invertebrates on the planet. They have to work really hard just to survive. I mean, they have to work really hard even just to see. So a case could be made that cephalopods can interpret color, but can't necessarily see it as you and I can see color. So if something is a very pure blue or yellow color, a cephalopod's eyes should be able to focus on that. So in coral reefs, where a lot of cephalopods live, It's a great environment because there are a lot of pure, bright colors there for them to hide against. So even though I'm talking like this is for sure the only hypothesis out there, it's absolutely not. Many, many decades of scientists and studies have concluded that cephalopods can see color. This is just the most common theory. There's still really no way to truly see through the eye of an octopus. So we kind of rely on computer programs, but to simulate what an octopus would be seeing, but we're still not entirely sure. So in response to the cephalopod's camouflage, we have to ask ourselves, is this a stimulus response, just something out of pure basic instinct, or is there actually some intelligence and cognition that is being used to create these patterns and this really deception that cephalopods are using? Now, for sure, some of it is instinctual. It's sort of like breathing. You can always breathe. You can always take a deeper breath. But you're also breathing all the time without even thinking about it. So it's a similar concept. So, but there is for sure evidence of intelligent camouflage, and I'm going to give you these 4 reasons that I found. So first, the development of camouflage is not rigidly fixed. For example, different cuttlefish, baby cuttlefish have a tendency to be able to adjust to new and different surroundings a lot better than older cuttlefish. They found in studies. So it's sort of like the old dog has a harder time learning new tricks. It's similar in that way. Secondly, depending on their environment, cuttlefish can adjust their skin patterns in relation to their own size. So that's evidence that they understand their body's position and they have at least a concept of how large or how small that their body is. If you've read any studies or seen any studies where animals recognize themselves in mirrors, people think that a lot of cephalopods would possibly be able to do that, which is a matter of intelligence. Thirdly, they don't respond to threats is an all or none response. Different predators elicit different responses. So let's say over time you learn that the barracuda can't see the color red. I don't know if that's true, but let's say they find out something about a predator, even a specific individual predator that, patrols the reef. They would learn from that and then create a different technique for camouflaging against that predator. And finally, there has been studies done that show cephalopods can change their body patterns in response to rewards. They can use their body patterning and as a way of involvement in learning and memory. So I just want to drive home this point again, that the molluscan brain evolves completely independent from the mammalian brain, which means the structure is completely different, and yet the level of intelligence that we can see within cephalopods is, on par with any mammalian brain, with gorilla's intelligence, with elephant intelligence, and that to me is the biggest evidence for the existence of intelligent life outside of Earth. If a planet can sustain life, I feel like it's almost guaranteed there's going to be some form of intelligent life on there. So that's just a little conspiracy for you and about my belief in aliens. So you can choose to believe or not believe, but to me, the octopus, squid, nautilus, and cuttlefish are the closest things to aliens we're ever going to find. at least within my lifetime. So that's all. I do want to address that I am not an expert in all this stuff. I have been now researching this stuff on my own for years, and I have read a lot of books, and I'm very interested in it. I'm working towards eventually studying this stuff, but I am not like a professor or a scientist. So I'm just a girl that likes cephalopods. So if I ever get anything incorrect, or if my facts are off, or if I've conveyed something incorrectly, please send me an email or message me on our Facebook page, Squiddish Podcast, and let me know, because I want to know, and I want to make sure that I correct my information in the next episode. So yeah, that's about all. Find us on Podbean, Buzzsprout, Spotify. I post on Facebook all the time, working on a YouTube channel to get up and going here, so there's a lot of ways you can find the podcast. That's about all I have for you. Once again, I'm Mel, and I'll see y'all next week.